Alright, I'm going to explain probably one of the better ways to remember how to simplify um, any radical expression with a square root. Um, we're not going to talk about different kinds of roots. There's such a thing as a cubed root, a fourth root, all that sort of stuff. We're just focusing on the good old square roots. What we do know about square roots is that they undo squares. So for example, the square root of 4 squared. Well, the square root of 4 squared is 4. Okay, this is an important concept to understand for what I'm about to explain to you. All right, the first step in simplifying something like the square root of 80. Let me separate these two problems. The first step is going to be finding all the factors of 80. Okay, so let's make a factor tree. It's probably the easiest way to go. We want all the prime factors, so we're going to go until we have all the prime ones. Well, I know 10 goes into 80. 10 times 8. And I know that 5 and 2 go into 10, and those are primes. I know that 2 and 4 go into 8, and I know that 2 and 2 go into 4. Now I have all prime numbers. The ends of my tree are all primes. So now, if I want to rewrite 80 as the square root of all these multiplied by each other, and I'm just going to go in order. We've got 4 2's, 1, 2, 3, 4, and a 5. Now, since a square root undoes a perfect square, let's look at where we have perfect squares here. So I'm going to rewrite, anytime I have 2 of the same number, I'm going to rewrite that as a square. Okay, so since we had 2 2's, that came down as a 2 squared, and another 2 2's came down as a 2 squared. And now, and keep in mind, when you get better at this, you don't have to do all of these steps. It kind of comes more naturally. But now we can rewrite this as 2 squared. I'm going to separate out these into the square root. And like we saw up here, the square root of a square, the square root undoes the square. So let's look at what happens here. So the square root of 2 squared, this is just 2. Square root of 2 squared, again, 2. And then root 5. All right, so now simplifying, final answer is going to be 4 square root of 5. And we're done. And you know you're done because the number in the square root, there were no perfect squares as a factor of that number. So since 5 is prime, we know that that cannot be simplified anymore. All right, let's move on to the next question. And I've actually changed my mind a little bit. Instead of 512, let's do 216. Okay, so again, we want to take 216 and break it into its perfect squares. So this might require a calculator. Since we know that 216 is even, we know that we can divide that by 2. Okay, so 108 and 2. And then we know that 108 is even. So we're going to divide that by 2 and we get 54. And 54 is even. So we're going to divide that by 2. We get 27. Okay, now 27 is 9. Okay, 9 and 3. And then 9 is 3 and 3. So clearly some of these trees are going to be longer than others. Okay. Let's now do the same thing we did over here. We're going to write the square root of all of these multiplied by each other. So we've got 1, 2, 3. We've got 3 2's. We only want prime numbers here. And then we have 3 3's. If it helps you, you can cross them out as you write them down so that we make sure we've got them all. All right, and then again, we're only going to deal with the pairs of the same numbers. So 2 and 2 and 3 and 3. And now when we rewrite our square root, we're going to write this as 2 squared times 2 times 3 squared times 3. And we're going to deal with the m cubed a little bit later. And actually, sorry, I ran out of room, so I'm going to pull out those numbers and then we'll deal with the m squared. It's actually not terribly difficult to deal with that. So we could now take the step of rewriting these out. Or, if you'll notice, we just can pull out the 2 here. The square root of 2 squared. That's like pulling out a 2. Okay, then we're done with that. Square root of 3 squared. That's like pulling out a 3. And we're done there. And then what we're left with is 2 times 3 times m to the third. But I'm going to write m to the third as m times m times m. And then again, I can do the same idea. Okay, this is m squared. Okay, and therefore we can pull out an m because it's just like these numbers. We could pull out a 2 from a 2 squared. We can pull an m out from an m squared. So we've got 6 from right here. And then I'm pulling an m out. Square root of, okay, right here, this simplifies to a 6, and then we bring this m back down that we didn't use. So our final answer here is 6m square root of 6m. And that's how you deal with those variables. You write them out as their definition, m times m times m, find the pairs, and then pull out an m for each pair. And that is the gist of how to do this. There's other ways, but this is probably the simplest.